Think about the last package that showed up at your door. Somewhere behind that delivery is a chain most people never see. A truck, a driver, a route planned around traffic and fuel and hours of service laws, and a warehouse system built around one unchanging assumption, that someone has to be sitting in the seat. That assumption is everywhere in transportation. Planes need pilots, trucks need drivers, ships need crews, and every one of those humans needs rest, training, salary, and insurance, which is a huge share of why moving anything anywhere costs what it costs. For over a century, the entire logistics industry has been built around designing better vehicles, faster engines, smarter routes, while treating the person behind the controls as a fixed, unchangeable cost of doing business. Air cargo has felt that constraint more than almost anyone. A cargo plane is one of the most efficient ways on Earth to move something valuable and time-sensitive across distance. But building the runways, training the pilots, and maintaining the safety infrastructure around crewed aviation is staggeringly expensive, which is exactly why so much of the world's remote and hard-to-reach terrain still isn't served by air freight at all. But here's the part most people never hear about. Getting heavy cargo aircraft certified as safe for uncrewed operation isn't just an engineering problem, it's a regulatory one, and it's historically been the slower half of the equation. In the West, getting any new aircraft category approved for commercial flight typically takes 5 to 7 years of testing, paperwork, and review, and that's for aircraft with a pilot on board. Removing the pilot entirely, especially for something heavy enough to matter commercially, has mostly stayed stuck in prototype purgatory. Impressive demo flights that never quite turn into a certified, insurable, everyday aircraft. In 2024, a Chinese eVTOL company called Autoflight, based in Shanghai, and also known by its Chinese name Zhongfei Aviation, began clearing that exact regulatory wall with its carry-all cargo aircraft, the V2000CG. If you're into stories about the vehicles and machines quietly rewriting how the world moves things, hit like and subscribe so you don't miss the next one. There's more of this coming. Why did uncrewed heavy cargo aircraft take so long to become real? It wasn't because engineers couldn't build a drone that flies itself carrying a ton of freight. Prototypes like that have existed in various forms for years. The real bottleneck was trust, expressed through paperwork. An aircraft with a pilot has a human in the loop who can react to an unexpected failure, override a bad sensor reading, or make a judgment call no algorithm anticipated. Take that person out. And a regulator has to be convinced that the aircraft's automated systems can handle every one of those situations at least as safely, which means proving reliability across thousands of edge cases before a single commercial flight is allowed. In the United States, the FAA has been building out its framework for uncrewed and powered lift aircraft under a program that adapts existing rules originally written for helicopters and fixed-wing planes, and even the furthest along Western competitors, companies like JOUAV Aviation and Archer Aviation, have spent years working through staged testing and are still targeting full certification for their piloted passenger aircraft in 2026 or later. Notably, nearly every major American eVTOL company pursuing FAA certification has chosen to launch with a pilot on board first, deliberately deferring the harder problem of certifying an aircraft with no one in the cockpit at all. One company, Wisk, is a rare exception, working through a certification pathway specifically built for uncrewed passenger flight. And even that program has needed entirely new airworthiness criteria written from scratch, because no existing rule fully anticipated an aircraft with nobody aboard to take over in an emergency. Europe's aviation regulator, ESA, has published its own dedicated framework for this category called SC-VTOL, but full certification of uncrewed, heavy-lift cargo aircraft under that framework has moved carefully and slowly, prioritizing exhaustive safety validation over speed. None of this caution was misplaced. Aviation safety rules exist because the cost of getting it wrong is measured in lives, not dollars, and every regulator building these frameworks has genuinely erred on the side of thoroughness. But it also meant that for years, the technology to build a heavy autonomous cargo aircraft was arguably ready well before any government was ready to certify one. The gap that closed faster than anyone expected. China's Civil Aviation Administration, known as the CAAC, took a different structural approach. Certify simpler, lower-risk categories of autonomous aircraft first, gather real operational safety data from those, and use that evidence to build confidence for certifying larger and more complex uncrewed aircraft. That strategy started paying off with EHang's EH216S, a small autonomous passenger aircraft that received its type certificate from the CAAC in 2023 after roughly 40,000 test flights over about 31 months, a fraction of the 5 to 7 year timelines common elsewhere. Autoflight's carry-all followed a similar but even more demanding path, because it isn't a small passenger drone. It's a genuinely large aircraft. The V2000CG has a maximum takeoff weight over 2 metric tons, a payload capacity of roughly 500 kilograms in its cargo configuration, a carbon fiber composite airframe, and a hybrid lift and cruise design, 8 dedicated rotors handle vertical takeoff and landing, while 2 forward-facing propellers take over for efficient horizontal cruising, meaning it flies more like a small plane than a hovering drone once it's airborne. The aircraft has no tilting rotors and no moving control surfaces during the transition from vertical to forward flight, a deliberate design choice that reduces mechanical complexity and gives regulators fewer moving parts to worry about failing. Its propulsion system is distributed across multiple independent electric motors, which means the aircraft is designed to still land safely even if one or more individual propellers fail mid-flight, a redundancy principle borrowed directly from how modern multi-engine passenger jets are built. The company developing it, Autoflight, is backed in part by CATL, the world's largest electric vehicle battery manufacturer, which has invested specifically in pushing battery energy density in aviation-grade cells toward levels that support longer eVTOL range. A reminder that much of what's making heavy autonomous aircraft possible right now is really progress, borrowed from the electric car industry's battery research. In February 2024, the CACI completed compliance verification testing on the carryall across more than 30 separate test categories, covering everything from its lift and thrust systems to its composite blade structure, battery system, and avionics, a testing campaign that included over 156 individual flights and more than 10,000 kilometers of cumulative flight distance. The following month, in March 2024, the carryall received its type certificate from the CAAC, becoming the first certified large cargo eVTOL of its kind anywhere in the world. Put those two documents together with the aircraft's individual airworthiness certificate, and the carryall became the only aircraft in its weight class anywhere in the world to hold the complete trio: design approval, manufacturing approval, and flight worthiness approval, all from the same regulator. That matters specifically for a country built from more than 17,000 islands, where moving fresh produce, medical supplies, and emergency materials between islands has always depended on boats or limited, expensive network of small regional airports. Meanwhile, in the United States, Zhongfei Aviation and Archer Aviation, the two companies furthest along in the Federal Aviation Administration's own certification process, have continued advancing through stage testing for their piloted passenger eVTOLs, with Joby completing power-on testing of its first FAA-conforming production aircraft in early 2026 and targeting full-type certification later in the year. Industry analysts tracking the certification landscape have noted that China's CAAC reached commercial-ready status for autonomous cargo and passenger eVTOLs years ahead of Western regulators working through comparable frameworks, not because the underlying aircraft technology in the West is behind, but because the certification pathway for removing a human pilot entirely has simply moved faster in China's regulatory system. One industry analyst covering the sector described China's approach as giving its eVTOL manufacturers a multi-year operational head start. specifically because certifying simpler autonomous categories first let regulators build confidence incrementally rather than trying to validate everything at once. It's worth noting this isn't just an autoflight story. AHang's smaller EH216S became the first eVTOL anywhere to complete a full 4 certificate stack, adding an air operator certificate on top of its design, production, and airworthiness approvals, and is now flying regular sightseeing routes in Guangzhou and Hefei, which means China now has 2 separate companies proving out different pieces of the same regulatory playbook at the same time. Numbers from the field. Skip the marketing language for a moment and look at what's actually been measured and reported. During its formal CAC compliance testing phase alone, the carryall logged more than 156 flights and over 10,000 kilometers of cumulative flight distance without a reported safety incident, serious enough to derail the certification timeline. Its offshore oil platform operation in 2025 represented sustained flights over open water, a genuinely difficult autonomous flying environment where wind shear and the complete absence of emergency landing options raise the stakes considerably compared to flying over land. The Indonesia validation process itself involved a direct side-by-side comparison of CAAC and Indonesian DGCA airworthiness standards, multiple rounds of technical consultation, a full documentation review, and on-site inspections of Autoflight's facilities by Indonesian regulators, the kind of independent external scrutiny that tends to catch problems a company's own marketing wouldn't mention. How big could this actually get? Zoom out from any single aircraft, and the carryall represents something bigger than one company's product line. Proof that a heavy, genuinely useful autonomous cargo aircraft can clear a full commercial certification process, not just survive a demo flight. China has designated dozens of cities as pilot zones for what it calls the low-altitude economy, essentially treating commercial airspace below 3,000 meters as a new layer of infrastructure for cargo drones, air taxis, and emergency response aircraft, alongside existing roads and rail. Chinese government projections have put the potential value of that low-altitude airspace industry, covering roughly the space below 1,000 meters, at close to $500 billion by 2035. Spanning everything from parcel delivery to agricultural monitoring to intercity air taxis, with heavy-lift certified cargo aircraft like the carryall representing one of the more immediately commercially viable pieces of that broader bet, since freight doesn't require the same passenger safety psychology that air taxis still have to overcome. If autonomous cargo aircraft like the carryall become common at scale, the biggest impact may land hardest in places that have never had reliable air freight at all. Island nations, mountainous regions, and areas without the runway and crew infrastructure that crewed aviation has always required. Where a vertical takeoff aircraft with no pilot to house, train, or pay could make air cargo economically viable for the first time. Where the hype runs ahead of the aircraft. None of this means uncrewed heavy cargo aviation has already arrived everywhere, and it's worth being precise about exactly what has and hasn't happened yet. The carryall's core certification, and nearly all of its real-world operational hours so far, are grounded in China's regulatory system and Chinese airspace. As of mid-2026, it does not hold an FAA or EASA type certificate, and there is currently no established validation pathway for Chinese eVTOL certifications to be automatically recognized in the United States or the European Union. That's not necessarily a reflection of the aircraft's safety. It's a reflection of the fact that aviation regulators don't automatically trust each other's paperwork, and geopolitical tensions around technology and data security have made mutual recognition between Chinese and Western aviation authorities considerably more complicated than a straightforward technical review. Cost is another open question. A 2-ton autonomous cargo aircraft still represents a significant capital investment, and while it removes a pilot's salary from the operating equation, it introduces its own expenses in battery replacement, maintenance, and the ground infrastructure needed to charge and manage a fleet of them. Range is also still a real constraint. Current generation eVTOL batteries top out well below what a conventional turboprop cargo plane can achieve on a single tank of fuel, which is part of why companies across the industry, Autoflight included, are racing to bring higher density solid-state batteries out of the lab and into certified aircraft, a transition that's still in progress rather than finished. And the aviation industry, more than almost any other, moves cautiously by design. A handful of high-profile incidents involving autonomous cargo aircraft anywhere in the world could slow public and regulatory trust across the entire category for years, regardless of how strong any individual company's safety record has been up to that point. The honest picture is a technology that has cleared a genuinely difficult first hurdle in one country, with real commercial orders and real operational hours behind it, but that still faces a slower, uncertain path toward becoming a truly global standard. Go back to that package at your door for a second. The chain behind it, the truck, the driver, the fixed cost of a human in the loop, has defined how goods move around the planet for the entirety of modern commerce, And for the first time, a heavy aircraft capable of carrying real commercial freight has made it all the way through a full aviation certification process without anyone sitting inside it. That's a smaller, quieter kind of milestone than a rocket launch or a self-driving car unveiling, but unglamorous infrastructure changes like this one are usually the ones that end up reshaping the most lives, simply because so much of the world still depends on how cheaply and reliably things can move from one place to another. If you want more stories about the vehicles and technologies quietly rewriting global logistics before most people even notice, like this video and subscribe for the next one. And here's a question worth sitting with. If the biggest obstacle to autonomous cargo aviation turned out to be regulatory paperwork rather than the technology itself, what other futuristic breakthroughs do you think are actually sitting finished in a lab somewhere, just waiting on someone to sign off on them?